Hey guys, this is Coach Brian bringing you your 6.3 notes about exact values. So during 6.2, we learned about the 6 trigonometric functions. They provide numerical ways of describing angles. Numerical ways of describing angles. And those angles are in what we call standard position. Okay, standard position. And standard position occurs when theta is an angle. And I'm going to kind of go to the image down here so you can see it. We've got theta. And if we measure out, we start at our origin and we measure out at the angle theta, we eventually can reach a point that has coordinates x and y. And that's what we call, let me back up a step. Where that angle starts, if you want to think about it like that, along the x-axis here, we call that the initial side. And then wherever that angle actually ends up kind of opening up to, we call that our terminal side. And so we reach this point P that has coordinates x and y. And remember, the x comes from moving right or left. The y comes from moving up or down. In this case, we're moving right and we're moving up. But that could change based on any theta, So as we're measuring this out, we can see that we have our x side right here. We have our y side right here, and our terminal side, kind of our connecting side, gives us r. Now, we last class referred to these sides as, and I'll draw them kind of the same way they are in here, but we refer to these sides as from theta, opposite, adjacent, and hypotenuse. Let me write that a little better. Hypotenuse. And now taking this kind of graphical coordinate plane type approach, we can see that our y is actually our opposite, our x is our adjacent, and our r is our hypotenuse. Now, as we start thinking about them this way, we need a way to find r, which is our radius. We need a way to find it. Now, if we were doing this, standard, let's forget let's forget the plane, let's forget the x, y, r, all that stuff. If I just asked you to find the missing side of a triangle, you would probably use, if it's a right triangle, the Pythagorean theorem. So if C, let's start there, is our hypotenuse, we could say that it's the same as r squared. And if A and B are our sides, we could say that that's x squared and y squared. And then if we wanted to isolate r, we would need to find the square root. And so we'd be left with this formula right here, that r equals the square root of x squared plus y squared. It's the same as the Pythagorean theorem, just using these letters as we kind of shift to the coordinate plane and the unit circle. So using these new x, y, and r terms, we can take our sine, which we know is opposite over hypotenuse, and we can now start referring to it in a new way. From theta, our opposite side is y, and our hypotenuse is r. And we know that cosecant is the reciprocal of sine, and so we can also just flip it, and we get r over y. And we can do the same thing for cosine, which we know is adjacent over hypotenuse. And using our new letters, we could refer to that as x over r. For secant, we would flip that because they're reciprocal. For tangent, we have opposite over adjacent, which in this case would be y over x. And for cotangent, we would just flip it because it's the reciprocal. So as we move forward, it might take some transitioning time to go from saying SOHCAHTOA and opposite and hypotenuse, and those things aren't wrong, but we want to start thinking about it in terms of x and y's on a coordinate. So as we move into kind of bridging these concepts of SOHCAHTOA, our 6 functions, and our coordinate plane, we want to talk about if an angle occurs in a quadrant, what will its sign be? So to start off with, let's kind of revisit our quadrants here. We start over here in the top right with quadrant 1. And then we go counterclockwise to 2, to 3, and to 4. And in these quadrants, I'll draw some triangles to help you visualize it. In these quadrants, my x, let me start with quadrant 1. My x is positive. My y is also positive. And my r, my hypotenuse, is also positive. So I've got my x, my y, and my r. They're all positive. And just a side note here, r is always positive. Will not be negative. R is always positive. But in this case, I've got a positive x. Oh, let me switch back to my pen, not my highlighter. I've got my positive x. I've got my positive y. I've got my positive r. If everything's positive, going back up to my fractions right here, my yr, my xr, my yx, every single one of those will be positive. So that makes sense because in Q1, our x is positive, our y is positive, and the instructions here say circle the positive values. So I'm going to switch to this crayon so it's a little less bold. Every single one of these can be positive here. Now let's switch to quadrant 2. To get to quadrant 2, I have a negative x, but I'm still going up, so I have a positive y. So what that would look like drawn out is my x would go this way. That's my initial side, okay? Then from there, I would go, I'm going to draw it here so I don't cross over everything. From here, I would go up. That's my terminal side. And as I draw r from the origin, I would terminate at the point P. And so I've got a negative x, a positive y, and an always positive r. And if you started looking at these ratios up above, again, see how my x is negative? Any one of these that has an x in it, boom, 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 boom. Every one of the ones that has an x in it will be negative. So let's look at which ones those were again. That was cosine and secant, tangent, cotangent. So the only one that doesn't have an x is sine and cosecant. So those are going to be my only positives in quadrant 2. Now, going to speed up a little bit here. Quadrant 3 is our negative quadrant. And quadrant 4, just going ahead, is our positive negative quadrant. And when I'm saying this, I mean the x and the y, okay? The x and the y of any point that falls into that quadrant. So for Q3, sorry, my computer's restarting. For Q3, I would go this direction for my x, negative. I'd go this direction for my y, negative. And I'd go this direction with my r. My r is always positive. Got negative x, negative y, always positive r. So going up, looking at our ratios, the ones with xr, yr, those are going to be mixed signs, which means they're going to be negative. But when I get to these two, they will end up being negative over negative, which is positive, all right? Which is positive. So as I get into quadrant 3, the only thing that can be positive is anything related to tangent or cotangent. And then for my last quadrant, if I go right, positive x, down, negative y, sorry, that arrowhead was horrible, negative y, and then I connect using my r, my terminal side, my radius. I've got positive x, negative y, always positive r. So anything that has the y in it, look up here, right there, right there, right there, right there, those will all be negative. So what does that leave me? It just leaves me cosine and secant. So I'm going to circle the cosine right there, and it's reciprocal. Now, an easy way to remember this, starting with quadrant 1, is the mnemonic, all students take calculus. All of the trigonometric functions in Q1 are positive. In Q2, just sine and its reciprocal, so that's where the S comes from. In Q3, just tangent and cotangent. And in Q4, just cosine and secant. All right, so let's put some of this to use. We have a couple of examples. Example 1 says find the 6 trig functions of theta if the terminal side passes through -4, -3. So here's how we want to start. If you need a ruler, grab one. Most of these problems will start by putting a nice little quadrant system on your paper. So this particular question asks about a negative x and a positive y. If I look back up here, that is going to be in Q2. And if I plotted that out, I'd go left 4, and I'd go up 3. So I'd have this point over here, -4, 3. And if I want to go ahead and trace that out as a triangle, I can. Go left 4, up 3, and get my terminal side in there. So now let's kind of zoom in here. I'm going to add in theta. And I know that this side is -4, and I know that my y was 3. I don't know why my pen's... There we go. All right, so how do you find first your radius? Well, you could use the formula that we discussed earlier. R is the square root of x squared plus y squared. But hopefully you're getting to the point where as you see them more and more, you will recognize our Pythagorean triples or triplets. This one is sorry, my pen's kind of messing up. This one is a 3, 4, 5 triangle. And then they want me to find the 6 trig functions. So I'm going to go sine, got to push down hard. This is not wanting to cooperate. Tangent, and then I'm going to flip them to my cosecant, my reciprocals, my secant, and my cotangent. Now, just to recap here, sine is opposite over hypotenuse. The way we're saying that today is y over r. We're saying cosine is x over r, and we're saying tangent is y over x. And then for our reciprocals, we are flipping those. We are flipping them. So again, I know that's going to take some practice to get used to, and you can still, if you need to, write it out, make a chart every time you get a paper if you need to. But let's find our y. It's 5, excuse me, I don't know what, it's 3. Our r is 5, so for cosecant, we're going to flip that, 5 over 3. Our x is -4. Our radius, or our r, is still 5. And then for secant, we're going to flip that. Our tangent, y, we would go 3. X, we'd go -4. And then for cotangent, we would flip that. So it'd be x over y. And those are our trigonometric ratios. Example 2. Let's start by drawing a quick quadrant. Now this one tells me in the instructions that it terminates in Q3. So I'm actually going to move this over, maybe. And I'm going to kind of focus on Q3 here, since I know everything's happening there. And if we remember our signs for Q3, it's our negative quadrant. So the information that they give us is that the cosine of Q, which is, going back up here, x over r, that's our x and our r, is -5 over 13. Now remember, the hypotenuse, the radius, r, is always positive, so you don't have to guess which one of these is negative. The 5 is negative, so we go over 1, 2, 3, 4, 5. And then we know that our radius is 13, and so we don't know, what we don't know is this missing side, this y. We don't know what that is. Now, how could you find it? You could use the Pythagorean theorem. However, this is another triplet, a 5, 12, 13. Now remember, for these triplets to work, they have to be in that order. So the 13 has to be the hypotenuse, which in this case it is. And then the 5 and the 12 have to be the legs, which we know this one is -5. And this is our negative quadrant. So that means this one's also -12. So now we have all three sides of our triangle. The problem asks us to find the missing 5 trig functions. Which ones are missing? Well, they give us cosine, so we'll go ahead and put cosine theta, and we can go ahead and put its value since they gave it to us. And since we start with cosine, let's go ahead and jump to secant, which is just the reciprocal. And then we'll go to our sine, which is y over r, so -12 over 13, and we can jump to cosecant. Oh, my pen is frustrating me. Cosecant, which is just going to be the reciprocal. And then we can go to tangent, which is going to be y y over x. Negative over a negative gives me a positive. And then my cotangent is going to be the reciprocal. Sorry, my pen is really not wanting to make this video. So it'll be 5 over 12. Again, negative over a negative would give me a positive. And then lastly, we have example 5. We're going to start with our quadrant. It says terminates in Q2, so we'll just kind of make one focused on Q2 here. Q2, my x is negative, but my y is positive. So they say that the tangent of this angle is negative 8 over 15. And in the case of tangent, it's y over x. So we know in quadrant 2, x is negative, y is positive. So it's actually this one that's negative right here. I can go right here and fix that. The 15 is what's negative. So I'm actually going to go over here to negative 15, and I'm going to go up until about 8, and I'm just guessing here because I obviously don't have a quadrant plane. And I'm going to go ahead and sketch out my triangle. I've got my negative 15, my positive 8, and then I'm going to draw my radius, my hypotenuse, and start labeling my sides. So my y is 8, my x is negative 15. Now, we don't know r, and we could find it using the formula we discussed earlier, or using the Pythagorean theorem. They're the same thing, just different letters. And that would work, but this is a Pythagorean triplet. When the legs are 8 and 15, the hypotenuse is 17. So don't have to do any math there, and we have all of our sides. Now, they only ask us to find cosecant and cosine. So cosecant is the reciprocal of sine. So if sine is, I'm just going to make a little note, if sine is y over r, that means cosecant is r over y. So we want to take our r value, 17, and our y value of 8, and that's our cosecant. And then we want to find cosine. Cosine is x over r. Sorry, my pen is just x over r. So our x value is our negative 15, our r value is our 17, and that is our solution. So I hope this helped. Doing your classwork and your practice will definitely make it stick even better. So good luck moving forward, and ask your teacher if you have any other questions.